This is a hydrograph, sometimes referred to as a flood hydrograph or storm hydrograph. It is a graph which shows the discharge of a river related to precipitation over a period of time. In this video I will help you understand the main features of hydrographs and how to describe them. Hydrographs cover a relatively short time period, usually hours or days, as you can see in this example. Over the short term, hydrographs show variations in precipitation, typically rainfall. Here precipitation is measured on the y-axis in millimetres. They also show variations in river discharge, which is the volume of water passing a point in a river each second, measured in cumecs, cubic metres per second. Notice there are two scales on the y-axis. The amount of precipitation measured during a rainfall event is shown in a bar graph. In this example, there has been heavy rain for 4 hours, followed by a drier period. River discharge is displayed as a line graph. Prior to the rainfall event, the river discharge was approximately 5 cumecs. But as the water is transferred to the river, the discharge increases. This is called the rising limb. Water is still moving to the river after the rainfall event, and discharge continues to increase until it reaches what is called peak discharge. Lag time is important because it shows how quickly water is transferred into the river channel during and after a rainfall event. The shorter the lag time, the greater the risk of flooding. Lag time is the difference between peak rainfall and peak discharge. In this example, it is 5.5 hours. As rainfall stops, water transferring to the river slows and discharge decreases. This is called the falling limb. Discharge is returning to the normal flow of water in the river. We call this the base flow. Above the base flow is the storm flow. This is the water that has arrived in the river via surface runoff or rapid through flow. The river has a limited capacity within its banks. If the bank full discharge is reached, the river will break its banks and flood. Let's compare the hydrographs of two small rivers experiencing the same rainfall event. Hydrograph A is flashier than hydrograph B. It has a higher peak, 25 cumecs, as opposed to 10 cumecs, and a shorter lag time, 5.5 hours, in contrast to 18.5 hours. The rising limb for hydrograph A is much steeper than that for hydrograph B, as is the falling limb. The falling limb flattens for hydrograph A after about 16 hours from the start of the storm. But this feature is not present for hydrograph B until after approximately 22 hours. Flashy hydrographs, such as hydrograph A, have a steep rising limb and a small lag time. This indicates that river discharge increases rapidly over a short period, indicating rainwater reaches the river very quickly. This means the river is more likely to flood. A gentle hydrograph, such as hydrograph B, shows the river is at low risk of flooding. These types of hydrographs have a gentle rising limb and a long lag time, which means it takes longer for the peak rainfall to reach the river channel, so the river discharge is increasing slowly. There is a follow-up video on the channel looking at the factors which affect the shape of hydrographs. Thank you for watching.